Greetings to all, my name is Pamela Palate and I am a research student at the Paulista State University on UNESP. It's a pleasure to be here and share with you the work presented image acquisition by stable diffusion adaptation with LoRA. Study objective: personalization of image generation with stable diffusion, fine-tuning using LoRA, training with personal photographers, automatic evaluation using facial similarity metrics. This research aims to determine if it's possible to customize stable diffusion to represent the specific face using LoRA, a lightweight fine-tuning technique. My own photographs were used and the similarity was then measured using space embeddings. My results: significant improvements in facial feature fidelity, efficient and low-cost training. LoRA provides viable for fast personalization. The results showed that LoRA can capture facial features with high fidelity without requiring large computational resource. What is generative AI? Create text, image, video, music, voice, code based on deep learning and transformers capable of mimicking human creative tasks. Generative artificial intelligence is a subfield of AI focused on creating entirely new content. What's interesting is that it can generate text, image, video, music, and even code remarkably mimicking human creativity. This technological leap was made possible by deep learning, especially the use of transformers and massive volumes of training data. Its impact today is enormous. It's transforming entire industries and automatically create tasks that previously only humans could perform. Main generative models: variational autoencoders, transformers, GANs, diffusion models. Generative models have evolved considerably, but allow for the generation of coherent variations of data. Transformers such as BERT and GPT revolutionized sequence handling. GANs introduced the concept of a competing generator and discriminator, but they suffer from instability issues. This is with diffusion models have gained prominence. They offer cleaner results and are easier to train. This comparison is key to understanding where generative AI is headed. Diffusion models. Diffusion models where we gradually adding noise to an image, then learning to reverse that process and reconstruct it. This research process is what allows image to be generated from scratch. Their main advantage over GANs is stability. They don't require two competing networks, but rather a more controlled predictable process. This reduces the risks of model collapse and produce more consistent results. Text to image: within generative AI, to text to image conversions is one of the most popular applications. Second, only to text, it works by combining a text encoder that understands the prompt and a spatial decoder that transforms it into an image. Models like Stable Diffusion, DALI, and Midjourney have driven a revolution in design and visual creation, facilitating the generation of hyperrealistic of artistic images in seconds. Challenging image generation, the speed its capabilities in image generation still face several challenges. One is in inference time. Creating high quality images is computationally expensive. Uh, they are of also difficulties in maintaining consistency when the prompt is long or complex, and furthermore, there are visual consistent issues between different phrases of the same prompt. Their challenge motivate the need for techniques like LoRA to customize models and improve the quality of the final result. Stable diffusion is based in latent diffusion models which operate in a compressed latent space instead of the entire image space. This drastically reduces computational costs. The process converts text into semantic representation, which is then transformed into an image. This architecture is very flexible and precisely the foundation upon which LoRA can be built. LoRA, low rank adaptation. LoRA is a technique that allows for the efficient uh, customization of large models instead of adjusting all the model's parameters. It only trains low-range matrices. This reduced time, memory, and cost is ideal for customizing styles, characters, or face without the need for extensive fine-tuning, which could to take hours or require by power GPU. Central objective. The main objective is to customize stable diffusion using our photographs, maintaining visual and semantic consistent. We aim to do this with the fewest resource possible and evaluate the model's fidelity using objective metrics. This approach encapsulates the motivation behind the work. Text to image research lines. Current research focuses on improving consistency in long prompts, increasing semantic fidelity between text and image, and comparing the performance of models such as DAL, Midjourney, and Stable Diffusion. A key point is that many of these improvements are achieved through prompt engineering, optimizing how, how prompts are written. Versatile diffusion. Versatile diffusion is a multimodal, multitasking model that can convert text to image and image to text. It uses autoencoder, KR, Optimus, and Clip, giving it great flexibility compared to stable diffusion. Its advantage is multimodality, but SD remains more special for customization and general use. SD is stable diffusion. LoRA in the literature. In scientific literature, LoRA is widely used for visual personalization because it allows for training models with low computational costs. It's used to adapt specific styles, personalize characters, and improve the fidelity of human face without modifying the entire model. LoRA applications. LoRA has been applied in multiple areas. It improves facial clarity, is used in industrial inspection for visual detection, has been incorporated into machine translation, and allows for the correction of common anatomical problems such as hand shape. This demonstrates its great versatility. Computing environment was implemented on ROM using a RTX 3090 GPU. We work with 20 gigabytes for the container and 50 gigabytes of additional storage, plus HTTP access and Jupyter Lab. This is important because a local environment well don't have enough capacity to run broadcast models efficiently. Tools used, the main tools were Stable Diffusion as the base model, Koya SESE for training LoRA, Automatic 1111 for evaluation, and BARM for processing to phase image, to general flows goes from preparing the image, training the LoRA model, and finally evaluating its quality. Stable Diffusion version 1.5, Koya SS for LoRA training, Automatic 1111 for evaluation, bar phase processing, Koya SS installation. Installing Koya SS involves cloning the repository, creating a virtual environment, installing dependencies, and running the graphical interface. There's no need to go into detail about the commands. The important thing is that it provides a user-friendly interface for training LoRA. Dataset preparation. 25 personal photographies were used, which were cropped and aligned to center to face. In addition, a regulation dataset of women was used to prevent the model from overfitting. This helps maintaining a balance between learning the face and maintaining a general representation of the female class. Base model configuration, the realistic vision version 1.5 model was used to it due to its excellent ability to generate photorealistic images. The instant prompts for the character and the class prompt were configured simply as woman, ensuring balanced training parameters. These parameters correspond to standard values for LoRA. A low batch size allows training even with limited GPUs. The network rank of 8 defines the model's ability to learn new features without overloading the training. The learning rate of 0.0001 and the cosine Chandler allow stable and progressive learning, and the repeat serve to reinforce the image of the dataset. Training process. The training completed 10 000 total steps, generating a checkpoint for each epoch. Each of these checkpoints allows you to evaluate how the model evolves during training. The JSON configuration file stores the parameters used, which make this easy to replicate the process. In terms of timing, training usually lasts approximately 1 hour depending on the GPU. Initial evaluation. The initial evaluation was performed by integrating LoRA into automatic 1111 image generated with and without LoRA were compared to observations in fidelity. The XYZ plot allowed visualization of the evolution over time, showing how the appearance of the face progressively improves. Visual comparison. Visual comparison shows that image generated with LoRA better preserve facial features, especially eyes, eyebrows, and contours. As time progresses, the quality of the face improves and becomes more consistent. Dataset vs generate image comparison. 5 generate images achieved general coherence style varies with prompt. The first thought is auto real date. The set your second image is a result of image trained with LoRA and stable diffusion. When comparing real image with the generated ones and acceptable overlap consistent is just right. The aesthetic variations between images depends on the style of the model, which is normally in diffusion models. The important thing is that the personal features are maintained. Similar metric is fades. Instant phase was used to obtain facial embeddings and calculate similar using the cosine metric. A value of 0.6 indicates that the generated image shares important structural features with the original image, although there is still room for improvement. Values around 0.3, 0.4 show partial similarity. Base generate image. The base image achieved a similar close to 0.6 key features such as a face shape, expression, eyebrows, and overall structure were captured. To obtaining even more accurate results, it will be advisable to increase the number of photographs in the dataset. Results interpretation. The result shows that LoRA is capable of capturing distinctive features even with a small dataset. Performance is satisfactory, but there is room for improvement by adjusting parameters, adding more images, or refining the base model. This opens the door to future optimizations. Final conclusions. LoRA proves to be an efficient and cost-effective technique for facial personalization in generative models. It achieves acceptable results with few images, requires minimal computational resource, and integrates easily with existing tools. The study provides practical evidence of these usefulness in real-world scenarios. Future words increase dataset size, that's never biased models, user perceptual evaluation, integrate control nets. Thank you for attention.